So solving equations is one of the tougher topics because I don't have they always turn out like this kind of thing. You kind of just need to look at what is there and think about the tools in your toolbox for how you would solve it. So there's a bunch of different ways you can go about solving these. So I've got methods there. We're going to make a little list, but you kind of just need to look at it and see what you have. The good news, though, is you do get a calculator for these, or I don't know if you consider that a good thing or not, but you do get a calculator to type in your answer. And this is the first time we've ever really come across this. So I'm going to make a little note off to the side. Whenever you're doing anything with a calculator, you need 3 decimal places. And the reason why I require 3, and I'll mark it wrong if you only do 2, just like Delta Math does, if you don't, round to the right number, it'll mark it wrong. Because on the AP exam, they want 3 decimal places. And I know you won't all go on to AP Calc, but I can't separate you guys into those going on and those not. I have to grade you all the same. And so the rule is 3 decimal places, okay? At least it's not significant figures. Okay, just 3. More good news is you can do what's called truncating. We're going to truncate, which means you don't have to round. I call it the first 3 that you see. So the first 3 that you see, you just take the first 3 decimal points and chop it off. Make sense? Okay, so we are going to use calculator for this. So looking at number 1, do you see how there's an 8 and then also a 4? Our first method is get the same base on both sides. So if you see numbers that kind of jump out at you, like you should look at that and go, oh, there's an 8 and a 4. What base could you turn those both into? And hint, it's a little number. The bases are always going to be pretty small. Get 2, just 2 kind of like let your instinct kick in. All right. So 2 to what power will give you 8? 3. Good. So you're going to write 2 cubed. And then do you see how there's a 3x minus 1? That just stays. You simply give it a hug. It's just there. So we rewrote the 8 as 2 cubed. Equals on the other side. Now the whole point is to make them the same. 2 to what power gives you 4? 2. 2 squared is 4. And then that x plus 2 is kind of just there. Now, once the bases are the same, and you're going to love this, you can simply get rid of them. So they're the same. I don't want to say cancel out because that's not really what's happening here, but they, for lack of a better word, they cancel out. Are you following me there? And so now you have an algebra 1 style problem. You're going to have this equals this. What would you do with this 3? Yeah, distribute. That's going to give you 9x minus 3 equals, and then distribute the 2 on this side, 2x plus 4. And it makes it a much simpler problem. So then what? Yeah, minus your 2x. Add 3. Divide by 7. I got x equals 1. So we didn't even need a calculator for that one. So let's try that again. Do you see how we have a 4 and a 1/16? What's a base number? Kind of let your instinct kick in. 4. If you were thinking 2, that's not wrong either. You could actually do 2 or 4 in this case. I would do 4 simply because I don't have to change this one. It already is a 4. So just like, hey, Miss Cole, looks like you just recopied it. Sure did. 4 to what power gives you 1/16? Good. -2. Why is it negative? Because it flips it. And then there isn't even anything else there, so that's it. Do you see how they're both 4? Those drop out. You get x squared minus 3x equals -2. Now, that's not so much an algebra 1 problem. That's more an algebra 2 problem. Where would we go from there? Yeah, add the 2. I call that evacuate. And then we're going to factor it. So what is that going to split into? Here we got x minus 3, x plus 1. All right, I'm so cold. All right. Oh, no, wait. It won't be 3 and 1. It'll be 2 and 1. There we go. And so you get x equals 2 and x equals 1. And that's fine. You're allowed to have 2 answers. So that's it. Now, when you look at this one, you should go, hey, wait, that method that we just did isn't going to work. Why not? Yeah, 2 to what power gives you 7? I don't know. I mean, there's some weird decimal, but I don't know what it is. So that method is not going to work. Instead, what you can do is use the correct log base. And I will show you what that means. But an exponential and a logarithm are inverses of each other. So you're going to use that to cancel out. It's kind of like when you're solving an algebra 1 problem and there's a +4 and you do a -4. Do you know what I'm saying? Like you're just doing the opposite thing. So do you see how this is log base, or sorry, I said it. Do you see how this is exponential base 2? We're going to do log base 2, and that will cancel that out. I guess you can write log base 2 on both sides. I tend not to do that so much because it feels very cluttered to me. So I wrote it on this one, and it's personal preference. If you want to, you can. That's probably the only time I'll do that, though. But what happens is the log base 2 and the exponential base 2 cancel, and you get x equals log base 2 of 7. And then what we're going to do is type that in the calculator. So let me make sure I've got my Desmos open. So on this test, you're going to have a portion that's non-calculator and a portion that's calculator. So let me share log base. Can't remember. I think that's in here. Actually, all this stuff is in the way. Let me move this. I'm pretty sure it's in functions. If you just noodle around in here long enough, you'll find it. Here, help me. It won't give you the base though. Oh. If you write log log, what is the base if it's not written? 10. So that'll give you 10, but there it is. So do you see how it has the, yeah, so it won't give you the subscript, unfortunately. All right, so log base 2, 7. Oops, that needs to go in the parentheses. And then there you go. We're going to truncate. And if you're in the back, you might not be able to see that. Bless you, but you'll be able to fool around with your calculator during the classwork. 2.807. Let's try that again. Looking at this one, what log base would you do to both sides? 4. Do you see how there's a 4 there? So, and you can write log base 4, log base 4. I tend not to do that because it looks really cluttered, but what you're going to end up with is 1/3 x equals log base 4 of 17. So you're just canceling out the exponential base 4 with a log base 4. And then what would be your last step to get rid of a 1/3? Yeah, multiply by 3. I would write it out front just because it's a coefficient. You could write it at the end too. Again, personal preference. And then I'm going to share my screen and we're going to type that in the calculator. So 3 log base 4, and what was it? 17. There you go. 6.131. All right, cool. Let's try a couple more. Do you see how this one has that 75 out front? Before I do a log base, how would I get rid of that 75? Since it's being multiplied, we would do what? Yeah, divide. We're going to divide both sides by 75. So you get 2 to the power 3x equals, let me see, let me type that in the calculator real quick. I don't know. Anyone want to guess? 225 divided by 75? I think it's a whole number. 3. Cool. All right, now what? Log base 2. And again, you can write log base 2, log base 2 if you want to. It would just look like this. Again, I don't really write that because it ends up looking really cluttered. And then what's your last step to get the x by itself? Yep, divide by 3. So we are going to type in log base 2 of 3 divided by 3. Log base 2 of 3, and then I want the whole thing divided by 3. So 0.528. Again, the first 3 that you see, you don't even need to think about it. It's called truncating. Are you guys hanging in there? Is this okay? But not too bad. Yeah, no rounding, no significant figures, first 3 that you see. But like, and I just said this, but you would not believe how many people on the test will only do 1 decimal point. And I'm going to mark it wrong. On the AP exam, they will give you nothing, as in like no points if you only do 2 decimal points. Like, so I have to get you ready for that. All right, I have this 7 out front, kind of like the 75 was out front. So first step would be divide by 7. And I'm just going to leave that as 2/7. it doesn't reduce, so just leave it alone. Now, what would you do to cancel out e? Like here it was a 2, we did log base 2. Here it was a 4, we did log base 4. ln, good. So 5x equals ln. And I am going to put parentheses around that one. You could put parentheses around all of them. Like over here, I could have put parentheses here. That's kind of up to you. I feel like when it's a fraction, it's a little bit more important, though, to put them in there. The calculator is going to put them automatically. All right, and then what's your last step? Yep, divide by 5. Now over here, you can just type ln, or you can find it in the like functions list. But let's see, ln 2/7, and then we want to divide that by 5. Negative, okay, look at this one. Can you see that in the back? I'm sorry, I know it's kind of small. Negative 0.250. You can round that 0 up to a 1 if you want, but I wouldn't bother. Truncate, first 3 that you see. But if you just put negative 0.25 and don't put the 0 there, then it's not 3 decimal points and they'll mark it wrong. Do you understand? Like it just the first 3. Now these last 2 are going to be a little bit different. For this one, do you see how you have an e to the 3x and then an e to the x? Sometimes you have to use your properties. And again, these are kind of like your tools in your toolbox. If you don't know what to do, this is sort of like your Rolodex. Like, hey, let me think about what my options are for how to approach this problem. I'm going to see if anyone remembers this. When you are dividing, what do you do to your exponents? Good, perfect. Even a weekend happened. You guys remembered. Subtract. So 3x minus 1x is 2x. And now this problem is exactly like the one we just did. So sometimes you need your properties. If you were multiplying, what do you do to your exponents? Add them. Good, perfect, lovely. All right, what are we going to do to both sides next? ln. So you get 2x equals ln of 4. Here, if you want to put the parentheses, you can. We'll give a hug. And then divide by 2. So I'm going to type in the calculator, ln 4 divided by 2. 0.693. I think for today, we're going to do number 8, and then I'm going to do the word problem on the back. Can you guys manage to not lose this piece of paper between now and next time, and we'll finish it next time? Okay, that's what we'll do. Now, do you see how this one looks a little bit crazy? Your last kind of method, and here, you know what, I'll slide it in here, is called U substitution. I don't know who picked the letter U, but that's actually what it's called. Like if you look in the index of a textbook, it is called U substitution. I guess you could use a different letter if you want, but that's like what it's officially called. The point of substituting is to get rid of the most complicated part. The goal here is to take a complicated problem, focus, and make it look more simple. Okay, so looking at this one, you kind of let your instincts kick in. You want to let U equal the 6 to the x part. In other words, the complicated part. Now, when we go to substitute, this first term is going to be u squared. Let that marinate for a second. Why is it u squared? 6 squared is 36. Okay, thank you. Minus 7u equals negative 10. Bless you. And then the whole point is that is a much less complicated problem. What would you do next? We do want to factor, but first, yeah, add the 10, evacuate. Or is that what you said? Did you say evacuate? Okay, sorry, I just misheard you. And then factor. So we're going to get 2 answers. 10 is going to split. Yep, 2 and 5, they're both negative. Now here's the thing. It's u equals 2 and u equals 5, but we're not trying to find u, we're trying to find x. So you don't want to write u equals 2, you want to write 6 to the x equals 2. And 6 to the x equals 5. And then unfortunately, you then have one more step. How do you cancel out the 6? So how would I write it? Yeah, log base 6, 2. Good. And then this one would be log base 6, 5. And then you would put those in the calculator. Are you okay with me stopping there? You would just type it in. Okay, let's just do the word problem. And then, because I want you to have time to do your classwork. Yep, you would put that in the calculator, you would get an answer, and you would put that in the calculator. You'd get two different decimal answers. Just for the sake of time, I'm not going to make you watch me type that in again. Okay. In 1990, the world population was 5.3 billion. Does anyone know what it is right now? It's 8.1 or 8.2 because we just hit 8 billion like last year or something. So it's like 8 point something now. I remember when we hit 5 billion though, and it was like this big thing. Anyway, estimated rate of population growth is 1.6% a year. Here is that equation. Do you see that 1.6% in there? Okay, because if I made you write the equation, it's PERT. Do you see that it's PERT? Okay, you start with the 5.3, move your decimal point. Anyway, what is the predicted world population in 2022? 2022 already happened, so we're going to see if this is correct. Now, you wouldn't plug in 2022. You have to take 2022 and subtract what year? When did we start this? 1990. So that would be 32. So all you're going to do is take 32 and plug it in for time. We're going to use our calculator. Everybody just watch and make sure I don't mistype anything. Let me get rid of all this. 5.3, oops, 5.3 e to the power, oh gosh, what is that? 0.016 and then times 32, 8.843. So 8.843 billion. Nope, it's not. Yeah, so it is like a little over, isn't it?
We don't even have that much now.
Yeah. Yeah, it's like a little bit off, but close, right? I mean, it's not bad. It wasn't off by that much. Now this is when, so we're looking for the time, will the world population reach 10 billion? So you're going to take this whole thing and set it equal to 10, and we're going to solve it. That's the new thing that you're learning, is how to solve the equations. This has some decimals in it, but can I draw your attention to something? Do you see how this problem is not really any different from number 6? Just instead of a 7 and a 5, you've got these, okay? So your first step, how would you move over the 5.3? Yeah, divide. And guess what? I'm going to just leave it like that. You don't really want to reach for the calculator until the very end. Like wait until the very end to type the whole thing in, right? Then what? How do you get rid of E? ln. So ln of whatever that is. And then what's the last step?
Divide by.
Yeah, divide by that.
Yeah.
And so let me put it in the calculator, but don't stop listening to me as soon as I type this in, because there's actually one other thing we have to talk about, right? So this is going to be, let me get rid of this. ln of 10 divided by 5.3, close parenthesis, and then the whole thing is divided by 0.016. Okay, I'm going to actually round this one to a whole number, and you'll see why in a second. We're going to say 40, okay? So 40 years have gone by, but the question is when. So we want, in what year will the population hit 10 billion? How could we get that like final answer? Yeah, good. 1990 plus 40. So that's going to be in the year what? 2030, which is not very long from now. So let me ask you a quick question. Do you think we'll hit 10 billion people?
No.
2030? No?
No.
Why not?
So,
Okay, oh goodness. We're very optimistic here.